Hi guys, we are from Group 8. Today we are going to present about thermal analysis. Before we start, I will introduce our group members. My name is Afiq and my friends are MARDHIAH and Tan Kelly. So what is thermal analysis? Thermal analysis is a group of techniques that study the properties of material as they change with temperature or time. Result of this analysis will give the information on physical and chemical properties of a substance, such as enthalpy, thermal capacity, mass change, and coefficient of heat expansion. Next. So in this topic, we will cover about thermal gravimetric analysis, differential thermal analysis, and differential scanning calorimeter. Next. What is thermogravimetric analysis, TGA? It is a thermoanalytical technique that measures the weight change of a sample at a given time and temperature. It provides quantitative and qualitative information about physical change, whether weight lose or gain in the sample in response to the current temperature, heating rate in the atmosphere, whether it's inert or oxygen rich. So for the principle of TGA, in thermogravimetric analysis, the sample is heated in a given environment such as air, nitrogen, and argon at a controlled rate. The change in the weight of the substance is recorded as a function of temperature or time. The temperature is increased at a constant rate for a non-initial weight of the substance, and the change in weight are recorded as a function of temperature at different time interval. This plot of weight change or mass percentage against temperature or time is called thermogram or thermogravimetric curve. The measure weight loss curve gives information on change in sample composition, thermal stability, and kinetic parameters for chemical reaction in the sample.
The instrumentation of TGA is consisting of the following component. First is the balance. It must be highly sensitive analytical balance. It must be precise and accurate at experimental temperature. The commonly used balance is current electrode balance. It functions as null-type device by providing an electrical force to restore the beam to a predetermined position. When mass change, the beam of the balance also change. A shutter fixed to the beam change the amount of light reaching the phototube or electromagnetic reading, which causes a restoring force to be generated by passing a current through the electromagnet that serves as the pivot for the balance beam. A permanent magnet above and below the pivot provides the magnetic attraction to the electromagnet. The force required to restore the beam is proportional to the current which is recorded. Secondly is furnace or heating device. Here, the sample is heated by resistant heater, IR radiation or microwave radiation, or heating can also be done by passing the hot vapors of liquid or solid. The furnace must be designed in such a manner that heat produced is directly given to the sample. The rate of increase of temperature must be 0.15 to 2 degrees per minute. The heating should be done in such a manner so that the weighing system should not be affected. Next is sample holder. The sample holder should be made of glass, stainless steel, or platinum. The size and shape depends on the weight and nature of the sample. Temperature measurement and control unit. The temperature measurement is done by thermocouples. It is placed very close to the sample. The EMF generated by the thermocouples when heated is recorded and applied on the x-axis of the data equation and manipulation system, which is computer. The result of thermogravimetry depends on the atmosphere of sample. The atmosphere should be inert gas called purge gas, which may be argon or nitrogen. So, let's discuss working of this instrument. First of all, the temperature of the sample is sensed by the temperature sensor, that is thermocouple. This temperature is sent to the computer, and computer sends the information to the temperature controller to increase the temperature. And as the temperature of the furnace increase, the sample may undergo into decomposition, so it will lose some weight and it becomes lighter. So, the pans of the balance move upward and the reference weight move downward. During this movement, The mirror attached to the balance reflects the light at a certain angle. This deflection in light beam is recorded by the computer, and computer again sends the required amount of the current to the magnet so that the reference weight is again pushed upward and mirror is moved to its horizontal position. The amount of current supplied to the magnet depends on the weight loss. So finally, this is converted into the weight loss of the system, and which is recorded on the graph in the y-axis, while the temperature is recorded on the x-axis. Finally, we can get a graph of loss in the weight versus temperature or time.
So, for data analysis and calculation, the question when calcium oxalate monohydrate is heated during a thermal analysis, it undergoes three stages of weight loss from the following processes. First stage is loss of water at 130 degrees Celsius. Second stage is loss of carbon monoxide at 500 degrees Celsius. And third stage is loss of carbon dioxide at 650 degrees Celsius. So calculate the weight percent loss for each step for heating of calcium oxalate monohydrate and sketch a thermogram curve which may be produced. Atomic mass were given. Okay, so for the solution, first we must determine the chemical reaction involved. Calcium, for the first stage, calcium oxalate monohydrate will be heated and decomposed to form calcium oxalate and water. Water will decompose first at 130 degrees Celsius. For second stage, calcium oxalate will be heated and decomposed to form calcium carbonate and carbon monoxide. At temperature of 500 degrees Celsius, the carbon monoxide will be lost. And for the third stage, calcium carbonate will be heated and decomposed to calcium oxide and carbon dioxide. Carbon dioxide will be decomposed, will be lost at temperature 650 degrees Celsius. So for the calculation of percentage weight loss for calcium oxalate monohydrate in the first stage is loss of water. So the molar mass of water will be divided with molar mass of calcium oxalate monohydrate. So the value that we get 12.3%. And then for weight loss for calcium oxalate, it loss of carbon monoxide. So carbon monoxide molar mass will be divided with molar mass of calcium oxalate. So the value we get is 21.8%. And the third stage, weight loss for calcium carbonate, it loss of carbon dioxide. So molar mass of carbon dioxide will be divided with calcium carbonate, and then we will get 43.95%. So this is the thermogram curve. After we get the weight percentage loss of the compound, we can sketch the thermogram graph. So this is how it looks. So factor that affecting the TGA curve, first is instrumental factor. Instrumental factor consists of furnace heating rate and furnace atmosphere. And second is sample characteristic. Sample characteristic consists of weight of the sample and sample particle size. So application of TGA to study composition of multi-component system, and second is to study thermal stability of material. Third is to study the composition kinetic of material, and fourth is to study the oxidative stability of materials. Next. So for the limitation of TGA, first is it is applicable to solid compounds only, and second is the data interpretation is not always straightforward. So next, I will pass the presentation to my friend Kelly.
Thank you, Alif. So what is differential thermal analysis? Differential thermal analysis is also called as DTA, which is a technique based on measurement of the difference in temperature between the sample and an inert sample material. It is used to study any physical and chemical processes that involve absorption and evolution of heat. What is the principle of the differential thermal analysis? The temperature difference between the test sample and an inert reference sample is under control. Heating or cooling is recorded and the heat absorbed or emitted by a chemical system is determined.
Next is the DTA instrumentation. The instrumentation consists of furnace. Furnace is operating from the temperature of 170 to 280 degrees Celsius. The temperature varies from 0.1 to 30 degrees Celsius per minute. The heating is done with the heated coil or IR radiation. Next, two wells of equal size, one for reference and the other one for sample. The sample is usually alumina. The reference and sample is places in the wells. Next come with thermocouple. The temperature of reference and sample and the difference between two temperature is measured with the help of thermocouple, which is the combination of two metal wells. Next come with amplifier. If the temperature difference is small, it is difficult to measure accurately. Then it is to be amplified with amplifier. And also the atmosphere control. The heating of sample and reference is done in the presence of inert atmosphere. In other cases, the reference or sample may react with the gases of the atmosphere. Finally, there is a recorder. Very sensitive recorders are used. It may be photographic light beam galvanometer or electronic potentiometer. A 2-point recorder records both the temperature difference and reference material temperature as a function of time or temperature reference on the axis. A recorder will give graph, which on the analysis we can have quantitative analysis, and from the graph we can decide the change whether it is physical or chemical change.
If any reaction takes place in the sample, then the temperature difference will occur between the sample and the reference material. So for endothermic change, such as melting or dehydration of a sample, the temperature of the sample is lower than the temperature of the reference, so the temperature difference is negative. However, for exothermic change, the temperature of the sample is higher than the temperature of reference, so the temperature change is positive. So this is the DTA curve, and the shape and the size of the peak give information about the nature of the test sample. So for the sharp endothermic peaks, it indicates the phase changes such as melting or fusion, which is the transition from one crystalline form to another crystalline form. And for the broad endothermic peaks, which is obtained from the dehydration process. However, the chemical reaction like oxidative reactions are exothermic reactions. Next is the DTA curve of decomposition of calcium oxalate monohydrate. The thermogram shows the decomposition in carbon dioxide atmosphere and in air atmosphere. So, the thermogram of calcium oxalate monohydrate has 3 peaks corresponding to the successive elimination of H2O, CO, and CO2. These 3 points of weight loss corresponds to the 3 endothermic process. So for the curve B, it represents the DTA diagram for the same compound in air. So for the curve B, it represents the DTA curve for the same compound in air. The second peak in this curve is sharply exothermic, but correspond to the same weight loss as in carbon dioxide atmosphere. So this peak represents the exothermic burning of carbon monoxide in air at the temperature of the furnace. Next is the factor affecting the DTA curve. There are 2 factors that affecting the DTA curve, which is the instrumental factors and the sample characteristic. So for the instrumental factors is the size and the shape of the sample and furnace holder. And next is the material for which sample holder is made and its corrosive attack. For the sample characteristic, which is the amount of the sample and the particle size of the sample. Next is the application of DTA. The application of the DTA is used to study the characteristic of polymer material and to test the purify of the drug sample. It is also used to determine the heat reaction, specific heat, and energy change occur during melting. Last but not least, it is used to serve as fingerprints for different substances. Next, I will pass to Afrina.
Okay, thank you, Kelly. So the third part of thermal analysis is differential scanning calorimetry DSC. So what is DSC? DSC is a thermal technique that measures the energy absorbed or released from a sample as a function of time or a temperature profile. It is useful to make the measurements such as melting points, heat of reactions, glass transition, and also heat capacity. Okay, so we have two methods of DSC. The first one is heat flux DSC and the second is power compensation DSC. So it measures two different things where heat flux measures the temperature difference while power compensation measures the difference of thermal energy per unit of time. So this is the diagram of heat flux DSC. Okay, for the principle of heat flux DSC, we have the 5 principles. First, the heat of heater is supplied into the sample and the reference through the heat sink and also heat resistor. Then the heat flow is proportional to the heat difference of heat sink and holders. In case the sample occurs, whether it is endothermic or exothermic phenomena such as transition and reaction, the endothermic and exothermic phenomena is compensated by heat sink. Then the temperature difference between the sample and the reference is still kept constant, but the difference in the amount of heat supplied to the sample and the reference is proportional to the temperature difference of both holders. So by calibrating the standard material, we can know the unknown sample of quantitative measurement. So this is the diagram of power compensated DSC. We have 3 principles of power compensated DSC. The first one, the temperatures of the sample and reference are kept identical to each other while both temperatures are increased or decreased linearly. Then, due to the small heating units are employed, it is allowed for the rapid rates of heating, cooling, and equilibration. Then the power needed to maintain the sample temperature is equal to the reference temperature is measured. So that's why we can get the curve of power versus temperature.
Now, I would like to tell on how does DSC work. During a DSC experiment, the protein in the desired buffer is placed in the sample cell. A match buffer is placed in the reference cell. At the starting temperature, the protein still retains its native shape and structure. As the sample and reference cells heat up, the proteins begin to thermally denature. The protein heat capacity Cp increases as the protein unfolds. The Tm is shown at the peak of the resulting data plot. At the end of the experiment, a protein is unfolded.
Okay, so this is the typical DSC curve. We can see that it is about the heat flux versus temperature. So as we can see, the exothermic peaks will be in the positive peaks and the endothermic peaks will be in the negative peaks. The exothermic peak means it releases the heat, while the endothermic peaks mean it absorbs heat. So this is the transition in a DSC curve. While the most exothermic peaks mean that it releases the heat, such as crystallization, polymorphic conversion, while the most endothermic peaks mean it absorbs the heat, such as the melting process, polymorphic conversion, and also denaturation. Okay, there are 2 factors that affecting the DSC curve. The first one is the instrumental factors, such as furnace heating rate, recording or chart speed, and the sensitivity of the recording system. While for the sample characteristic, it is like the thermal conductivity, the amount of sample, and also the particle size. Okay, so as we know, we have 3 DSC is very widely used in many fields, and the most popular three field is the first one is general chemical analysis, where it is used to know the freezing point depression that can be known as the purity analysis tool. The second one, in the pharmaceutical field, it is well characterized in drug compounds to define the processing parameters, and it is also to process the drug at which crystallization can occur. In the food science field, we can make it to know the water dynamics, as change in water distribution will also related to change in the water texture, and also we can also use in the effects of curing on confectionery products. Okay, so we already know about three methods of thermal analysis, which are TGA, DTA, and also DSC. But what is the difference of these three methods? So the first one, what it is measured? TGA measure the change of the mass of the sample with the change of temperature. DTA observe the temperature difference developed between a sample and a reference compound. And DSC measure the heat flow is measured against the temperature change at a particular time. And then TGA is used to analyze inorganic materials, metals, and so on, while DTA is used to analyze the thermal properties of the minerals for the characterization of polymers and biological matters, while DSC is used to analyze the proteins, antibodies, and so on. TGA and DTA can be used as a solid, the sample of TGA and DTA can be used as a solid substance, while the sample of DSC is always a liquid. Okay, as a conclusion, TGA, DTA, and DSC are thermal analysis techniques which can use to analyze the behavior of a particular substance when the temperature is changed. And last but not least, it is applicable for certain chemical reactions in order to find the relationship between the reactions and the temperature. So that's all from our group. Thank you.